Hello guys, this is our first revision video to help you get ready for the final examinations. And we're going to focus on paper 1, and today we are working with factorization. We're going to work through the following 8 examples, and as you can see, they are slightly different and they increase in difficulty as we go on. So in our examples, what we want to do is solve for x. And in our first example, we have x minus 2 in brackets, x plus 7 in the second pair of brackets equal to 0. Now, normally the temptation is to multiply out and then factorize and then solve for x. But this is not necessary because the equation is already factorized, so it's already placed in brackets. And simply what we need to do is make each bracket equal to 0 for this equation to be true. So I set the first bracket and the second bracket equal to 0, and I simply solve for x. So in the first bracket, if I make x equals to 2, the bracket will become 0, so 0 times that bracket will be equal to 0. And in the second bracket, if I make x equals to negative 7, this bracket will become 0, so it's x minus 2 multiplied with 0, which will also become 0. In this example, we also want to solve x, and we have 2 possible methods. We can either use the quadratic formula or factorize. Now, in my experience, factorizing is sometimes quicker if you can see which factors to use. So it is x squared, so it will be x in the first bracket, x in the second bracket. And I can see I have 16, and I need to use the factors of 16 to get to 6. So the factors of 16 is 1 times 16, 2 times 8, that will also give me 16, and 4 times 4. And I'm looking for a set of factors where the difference would be 6, and I can see it will be 8 and 2. So the values that I will use in my brackets are 8 and 2, and I want to create negative 6. So the 8 would be negative 8, and with the 2 it will be positive 2. And if I test, it is 2x minus 8x, which will give me the middle term of negative 6x. And now that I have factorized the equation, I can solve for x. And as in our previous example, I place every bracket equal to 0. So x plus 2 equals to 0, therefore x is equals to negative 2, or x minus 8 equal to 0, therefore x is equal to 8. In my next example, I want to solve x correct to 2 decimal places. Now this hints that I need to use the quadratic formula. But look carefully at the equation. It is not in standard form. So the first thing that you need to do is bring everything to the left side of the equation and place it equal to 0. Now this is called standard form. And once you have placed the equation in standard form, then you can apply the quadratic formula. Now remember, for the quadratic formula, you need an a value, a b value, and a c value. The a value is the coefficient in front of x squared. The b value is the number or the coefficient in front of x. And then the c value is the constant. And remember, we're taking the signs with. So a is plus 4, b is plus 9, and c is negative 3. Now you would find the quadratic equation on the formula sheet provided for you, so make sure you copy it correctly. And then the only thing that you need to do is substitute. So b is 9 plus minus, b squared is 9 squared minus 4 times a, which is 4, and the c value is negative 3. over 2 times 4. And now you can use your calculator and build this equation on your calculator. So I'm going to create a fraction, and at the top I have -9 plus square root of 9 squared minus 4 times 4 times -3 over 2 times 4, or 8. And now the calculator would produce an answer which is in surd form, but the instructions said correct to 2 decimal places. So I simply press SD on my calculator. So it's 0.29. Now I do not need to type in everything to get the second solution. I simply need to change the plus in front of the square root to a negative. And equal. And again, I press SD and I find the 2 decimal places, it is -2.54. And that's how I find my 2 values for x using the quadratic formula and my calculator. Now next example, we have 2x and in brackets 5x minus 3 equal to 0, and we want to solve x. Now this is the same as our first example. We do not need to multiply out and factorize again. We simply need to place 2x equal to 0, and we need to place the bracket of 5x minus 3 equal to 0. So if I can make this part 0, then this equation would be true. Or if I can make 5x minus 3 equal to 0, then 2x times 0 would be equal to 0 as well. So x would be equal to 0, or x would be equal to 3 over 5. Now remember, if I transpose the 3, it will become positive, and then I divide by 5 to solve x. In our next example, we have x squared minus x is equal to 30. And what we want to do is solve for x. But remember, before we can factorize or use the quadratic formula, we need to rewrite the equation in standard form. So it's x squared minus x minus 30. I transpose the 30, meaning I bring it over the equal side. That is now equal to 0. Now you can choose to use either the quadratic formula or factorize. And I hope that you're comfortable to see when you can factorize. So I have 2 values of x, so x and x. And I need to use the factors of 30 to create a -1. So the factors of 30 are 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Now these are our pairs of factors that will create 30 if I multiply them with each other. And I can see 5 and 6 has a difference of 1. So it will be x minus 6, x plus 5, because this will create 5x minus 6x, which will give me the middle term. And now I place both brackets equal to 0. So therefore, x is equals to -5, or x is equals to 6. Now next example, we have 3x squared minus 8x minus 4. Now you can choose whether or not you want to factorize or whether you are going to use the quadratic formula. In this case, I could see trying to factorize will take me a little bit longer, so I'm going to go straight for the quadratic formula. And remember, you can find this on the formula sheet. So the A value would be 3, the B value would be -8, and the C value would be -4. So notice our substitution. B is -8, the A value is +3, and C is substituted with -4. Let's build this fraction on our calculator. So I press the fraction sign, and this time I'm going to use the brackets. Negative bracket, -8, close the bracket, plus, put in the square root, bracket, -8, close the bracket, square, minus 4, bracket 3, close the bracket, bracket, -4, close the bracket, over 2 times 3 equals, and again my answer is in surd form, but in this example we were not instructed to leave the answer in surd form or in decimal, so both will do. So I can say x is equals to 4 plus 2 square root 7 over 3, or find the second value. Then I go to the fraction and I replace the sign in front of the square root with a negative. So x would be equals to 4 minus 2 square root 7 over 3. In our next example, we have x plus 2 over x plus 1 minus 3 over x minus 2 equals to 1 over x plus 1. Now before we start to solve for x, let us find some restrictions, because you can see we have denominators and these denominators are not allowed to be equal to 0. So there are restrictions on x. So here we can see that x cannot be equal to -1, because if I replace x with -1, the first and third denominators would become 0, and x can also not be equal to 2, because if I place x equal to 2, the middle denominator would be equal to 0, and we are not allowed to divide by 0. Next up, we want to find an LCD, a lowest common denominator. And if I look at the denominators, it will be x plus 1 and x minus 2. Even though we have 3 fractions, we see that we only have 2 different kinds of denominators, and I multiply them together to find the lowest common denominator. Notice I do not multiply them out. What I'm going to do is I'm going to multiply every fraction with the LCD in the numerator. That means at the top. So in the first term it is x plus 2, and see, I place it in brackets and I multiply it with the LCD, and I can immediately see that the x plus 1's would cancel out. And in the second term, I multiply -3 with x plus 1, x minus 2, and I can see that the x minus 2's would cancel out. And on the right-hand side of the equation, I multiply 1 with x plus 1 and x minus 2, which is the LCD, and I can see that the x plus 1's cancel out. Therefore, I have x plus 2 multiplied with x minus 2 minus 3 times x plus 1 is equals to 1 times x minus 2. Now I'm going to multiply out. So the first term would become x squared minus 4. Then -3 times x, -3 times 1. that becomes negative 3x minus 3, and that is equals to x minus 2. Now I can rewrite this equation in standard form. That will be x squared minus 3x minus x, because I transpose the x. Then it is minus 4 minus 3, and I transpose the negative 2, which becomes positive 2, and that is equal to 0. Now I can add up like terms, so it's x squared minus 4x, and then minus 4 minus 3 plus 2, which is negative 5. Now I am left with a simple trinomial which I can factorize. And when I solve for x, I see that x is equal to negative 1, or x is equal to positive 5. But now we need to go check the restrictions. And remember, right at the start, we've placed these restrictions on x because we do not want to make the denominator equal to 0. And I can see x cannot be equal to negative 1. So if I look at my final solution, I can say x cannot be equal to negative 1, therefore x is equal to 5. And in our final example, we have 2x squared minus x minus 1 plus 15 over 2x squared minus x plus 2 equals to 5. So if you try to solve x yourself, you would see that you will get stuck at some point. Most probably, people would try to factorize the first 3 terms and then factorize the denominator and then try to solve x from there. But many would fail to see that 2x squared minus x occurs twice. And you can replace 2x squared minus x with a single term. So what you can say is let k be equal to 2x squared minus x. Then the equation would become k minus 1 plus 15 over k plus 2 equals to 5. Now what I would do is rewrite this equation in standard form. So it will be k minus 6 plus 15 over k plus 2. It becomes minus 6 because I have negative 1, and I transpose the 5 to become minus 5. So negative 1 minus 5 will be equals to negative 6. Now in order to remove the fraction, I multiply everywhere with the denominator of k plus 2. So it's k times k plus 2 minus 6 times k plus 2 plus 15 times k plus 2 over k plus 2 equals to 0 times k plus 2. So before I multiply out, I can see here by the fraction that the numerator and the denominator have parts that I can cancel out. And now I can multiply out, so that become k squared plus 2k minus 6k minus 12 plus 15 equal to 0. And then I can add up like terms. So it is k squared minus 4k plus 3 equal to 0. I can factorize, so it will be 2 brackets equal to 0. K squared would be k and k. The factors of 3 is 3 and 1. Both would be negative to produce negative 4. So it's negative 1 minus 3, which will give me negative 4. Therefore, k is equals to 1, or k is equals to 3. But k is equals to 2x squared minus x. So I replace k, or substitute 2x squared minus x back in. And now I would need to solve x again. So I rewrite the equation in standard form and then factorize. So it'll be 2x and x, 1 and 1. And then I need to place the signs properly. So it'll become negative 2x plus 1 will give me negative x. Therefore, for this part of the equation, x would be equals to negative a half, or x would be equal to plus 1. And then I also need to solve x for this part of the equation. So it is 2x squared minus x minus 3 equal to 0. Then I'm going to try and factorize again. It's 2x and x, 3 and 1. So it's negative 3x plus 2x will give me negative x in the middle. Therefore, x is equals to negative 1, or x is equals to 3 over 2, or 1.5.